All right. Hi, everyone. Can people on Discord confirm that they can hear me on the stream? Maybe they can't. I think I'm streaming. All right, there's people typing. That's probably because the answer is yes. Yes. Okay, cool. Yeah, thanks for coming. So I'm going away, so this is going to be the last in-person lecture. I'm clearly not going to be able to finish everything that I wanted to do today. So what's going to happen is I'm going to land, hopefully, Friday evening. Then I'll figure out exactly how badly I'm jet lagged, and then I'll announce some online lectures. Okay. So what I want to do today is talk a little bit about data visualization, and also kind of both conceptually and in practice in R. So we are over here. So what makes for, so first of all, what's data visualization? Well, it's graphically summarizing the data somehow. So everyone, kind of, if you read like any textbook about data visualization, they will probably show you this chart, which is considered to be a classic of data visualization. So this would be Napoleon's march on Moscow. So of course, like, unfortunately, there's still war going on, but basically Napoleon decided to invade Russia. It did not go well. So this is the visualization of what happened. So basically what you have there is the size of the Grand Armée, so the Great Army of Napoleon. So this would be the width. And then if you go kind of along the horizontal, the x-axis, this would be the army moving spatially. You can also keep track of the size of the army. So here you see a visualization of, so some part of the army split up and then they met back here. You'll notice that this is kind of jagged. So those would be river crossings a lot of the time, sometimes battles, where not everyone survived. And what you see here is kind of the march on Moscow and then the retreat from Moscow here in black. So as you see, really did not go well. So that's considered kind of a classic of the genre. Because it's a creative kind of visualization that kind of like tells you a story in one picture, tells you kind of what happened. So, and here you have kind of dates, battles, stuff like that, right? So is it good visualization? Well, I mean, it kind of tells you maybe what happened. It probably also doesn't tell you the whole story. Well, if you can read French, there's more of the story there. But it's considered to be kind of good. It's also kind of non-obvious, right? So this is not just kind of, you know, do a y-axis, do an x-axis, and then just put points on the plane. It's something more complicated. So here's another example. Is this good? So this is, again, a somewhat famous example of data visualization. So here you have the total House and Senate campaign expenditures across the years in the US. So you see here that they're going up. So is it good? Well, it's memorable. It's not misleading. It's probably comprehensible. Is it as comprehensible as it could be? Well, one might argue, well, not really. Probably the fancy stuff is just distracting you. So what about bad data visualization? So again, kind of different people are going to have different opinions about what's good or bad. But widely in the data visualization community, anything with actually this is like almost the default in Excel, but anything like that, anything with 3D with shadows is considered an extremely bad taste. Why? Well, if you rotate things like that and then you make them 3D, you're actually being a little bit imprecise about the data that you're presenting, so you're just ruining the plot a little bit by doing this. The shadows are not adding information. At best, they're not adding information. Probably they kind of give you a cue that might be a little bit misleading. This is referred to, so junk chart is incorrect. So this is referred to as chart junk. So anything that's not actually presenting, anything that's not conveying information, like the shadows, are called chart junk. As the name implies, people usually don't like, well, I should say, people who think about data visualization a lot don't like it. Lots of people obviously like it a lot, which is why this is like the default in Excel. And you could argue, okay, like this is kind of considered a classic, and there is a lot of junk here too. It's just that it's arguably serving some kind of purpose of kind of drawing attention to the chart. So what about this? This is an extremely famous story. If you know, so like it's on YouTube as well. So basically, it would be, sorry, I don't remember the date, but sometime in the 70s, there was the Challenger disaster, so a space shuttle that exploded, kind of a little bit after launch. And then the problem, or at least according to Richard Feynman, the problem was the O-rings. So those would be kind of plastic rubber rings that were used in the construction of, sorry, I don't know the details, but were used in the construction of the shuttle. And apparently they were, like it was cold, and they were more stiff than they should have been, and they broke, is at least the claim. So famously, Richard Feynman, during kind of the Committee of Inquiry, dropped the O-ring into ice water and showed that it became more brittle as a result of that. What does this have to do with data visualization? Well, as it happens, so this is the best one I could get, so it's not very clear for reasons separate from data visualization, but actually there was a report about the effect of temperature on the properties of the O-rings. And the data visualization there looked like that. So unfortunately you can't read it at all, but you can kind of see that they have like pictures of rockets there. And well, you can't see it, but the data about the properties of their O-rings, which were not favorable, subject to what the temperature was, the data is actually there. It's just that there's so much chart junk there that people might not have noticed. So this would arguably be a much better figure that presents the same data. So this is the number of damaged O-rings per launch versus temperature, and you see that if the temperature is very low, then there is more damaged O-rings. So I don't want to kind of say that the person who made this chart, nobody knows who that is responsible for anything. That's probably not true. But it's an illustrative example of kind of bad data visualization. So this example is more contentious. So I took it from Kieran Healy's textbook, and like he has strong opinions. I'm not going to completely endorse those opinions, but here this is arguably an example of bad data visualization, where it's a little bit unclear whether it's really bad data viz or just bad data. So what's going on here? So the data here is on the percentage of people who say, if asked whether it's essential to live in a democracy or not. And what you see here, or at least kind of the way it appears in the New York Times, so this is a screenshot from the New York Times. So what you see is that percentage goes down everywhere from whatever, the 30s to the 80s, right? And kind of the story that you get from this, if you look at it and just think about, okay, what does it mean? Well, it seems like people are saying it's not that important to live in a democracy. So what it actually is, if you look at it, or look at the original data, is people were asked on a scale of 1 to 10, how important is it to live in a democracy? And this is plotting the percentage of people who said 10 out of 10, it's really important. So does it show something? Well, yes, something changed. Is it necessarily a good visualization of what's actually going on? Well, arguably not, or at the very least you need to look more, because it's very different whether people just stop saying 10 out of 10 to everything, right? So it might very well be that, in the 30s, it was like, do you like democracy? 10 out of 10. Do you like peace? 10 out of 10. Do you like cornflakes? 10 out of 10. And then kind of now everyone is kind of cynical and jaded. And like, do you like democracy? Well, like it's pretty important, 9 out of 10, but cornflakes might have gone down to 7. So you don't know. At the very least, you should check whether it's just a trend of people not saying 10 out of 10 to anything anymore because, well, there's lots of things in the world. They can't all be 10 out of 10. Not saying that that's the case, but you should check. And this is arguably kind of, well, it's presenting data that's there, right? So it really is the case that there were those surveys and this was the percentage of 10 out of 10, but it might be the wrong thing to visualize. So arguably, again, I'm not endorsing it 100%, 9 out of 10, but like 9 out of 10 I would say yes, Kieran Healy is correct and should not have been displayed this way, because you should not have been displaying the percentage of people saying 10 out of 10 in the first place. Probably something like the average would make more sense. And the average, in fact, if you look, I don't remember if it went down at all, but definitely nothing this dramatic. Because like what you see here is like it went down in Britain from like 75% to 25%. Like that's not representative of how British people think about democracy. So, okay. Yeah, in fact, sorry, I had it in the next slide. So there was a decline, but the decline is like this. And again, even if the decline is there in the data, it doesn't mean that the data, that kind of answers from the 30s and answers to the 90s are comparable. It might just be that people just started rating everything lower. In fact, pretty sure that's the case. So this is kind of like the Excel thing, which again, people in the data visualization community completely hate. So you display it like that. The data is there. In principle, you could figure it out, but it's very hard to see it from the chart. So that's considered bad practice. Like if you can make it so that the person can actually figure out what the data says from the chart, you should. Here, you're just obscuring information. Here's another example where, it's displaying something. So this is not any particular data set. And it might be the best you can do, but, look at this and look at the Napoleon's Grande Armée chart, and you would say, okay, like this is clearly uninspired. So whether it's bad or not, well, hard to say. Maybe this is the best you can do. Almost never is this kind of thing the best you can do. But you could say, okay, this is uninspired. So this is probably something that you will have been familiar, where this is kind of an example of not so much bad data visualization, it's just like a problem with like a deficit in honesty. So it's usually, as you probably know, very bad practice to cut off the y-axis somewhere where it's convenient rather than somewhere where it makes sense. So here, so this would be first year enrollment versus year. By the way, I say first year enrollment versus year. I don't know how many people know. So the convention is y versus x always in English. So this one you would say first year enrollment versus year, not the other way around. Just a convention. Anyway, so clearly, like, this suggests that there was something very interesting and important going on, where, you know, the enrollment grew and then it dropped by a lot, which is a little bit true, but actually the enrollment fluctuated around 40,000 most of the time. So usually a bad idea to cut things off anywhere that's not zero. Sometimes you kind of got to, right? And sometimes the zero is not really meaningful. So if you think about, for example, plotting the average temperature in Toronto over the years, well, it's not the case that it should be like starting from 0 Kelvin degrees, right? So 0 Kelvin is like minus 300 something, right? So not a good idea. But usually, especially here where the zero is very natural, the zero just is like 0 students, going up to 40,000 students, yeah, like you should probably, at the very least, have both charts. You might say, okay, I'll give you the chart on the right, and then I'll say, hey, look, like, I want to focus on the small trends, so given that you've already seen the thing on the right, I'll now show you the thing on the left so that you can more carefully look at the micro trends. That makes sense. So this is kind of, so we'll see example of this kind of thing. So usually this doesn't come up, but sometimes it makes sense to think about the psychophysics of things. So kind of what is psychologically easy to tell. So if you look at this, it's extremely easy to find the blue dot. If you look at this, it's again extremely easy to find the blue circle. If you look here, finding the blue circle is much harder. Right, so there it is. But that's much harder. For n equals 100, well, good luck with that. Okay. Yeah, I can't see where you're pointing, but I assume you did find it. So this is referred to as popping out. So color pops out, meaning is much easier to focus on, a lot more than shape, for example. Usually more data make things much more difficult, so kind of in here finding the circle is not very difficult, it's just annoying. Here it's very difficult. So usually what you want to do is you want to use color, for example, and case by case, just look at, kind of when you're doing visualization, just look at, okay, like, is it easy to figure out where the interesting points are or not? Can I make it different? This is one example where, like, it's well known that color is better than shape. Color plus shape is a little bit better than color only. So another thing that's kind of sometimes interesting when you're doing data visualization is thinking about how people perceive patterns in the data. So as you probably know, so kind of like you look at clouds and a lot of time you kind of think, oh, I think I see a face, right? And that's because humans just, you know, evolved in a way that makes them pay attention to anything that's even vaguely face-shaped, right? So faces is not a big problem. So like even if you see a face in here, it's like you're not going to be misled. A problem that does occur that's kind of conceptually similar to that is humans tending to see patterns just in anything where there aren't any. So, for example, this is completely, points that are generated completely randomly, so using something named the spatial Poisson process. So I think if you take the mass stats option, you'll get to it in stats 384 or something. But like some kind of random process. This, on the other hand, is non-random. So this is points that are generated by specifically trying to make it so that the distribution is kind of uniform. If the points are completely random, it might be that you'll see clumps of points just by chance. And in fact, well, it might be different for different people, but most people would kind of say, oh, like this looks more non-random because there's clumps of points there. In fact, that's the random one. And because it's random, sometimes just randomly, if there's enough points, you'll see clumps of points. And then most people, maybe not all, would say that this looks like it's random. They look pretty evenly spaced. And in fact, no, like it's a non-random thing where you intentionally make it so that there is never any clumps. So paying attention to this also sometimes makes sense in terms of you want to visualize the data in such a way that people who look at it won't be encouraged to see patterns that aren't actually there. Sometimes it's hard to do. It's just something to think about. All right, let me check the Discord. Okay, it's just yes. All right. So so by the way, so I really recommend Kieran Healy's book. So it's free online. It's this. So if you go to menu, there's like all the chapters. So obviously kind of there's a lot more stuff than what I can do in whatever the 50 minutes that I have today. So I think this is a really good book. It's also a pretty easy read. It also gives you kind of some good stuff about R, so I recommend it. So, okay. So the other thing that I wanted to do today was actually kind of practical visualization. So ggplot is the library that we're going to be using here, and this again, like all of it is stolen from Kieran Healy. So if you've made graphs before, it's a little bit different, and there is a little bit of a learning curve there, but it's very much worth it. So I'm going to first just give you examples of how it works, and I'll then talk a little bit about the overall design philosophy behind this. So basically what it is you're telling ggplot we're working with this particular data frame, so in this case Gapminder, and then Gapminder has multiple columns, right? So what you tell ggplot is, okay, like I'll consider one of the columns to be the x-axis and one of the columns to be the y-axis. So this is how we're specifying it. So this line by itself just tells ggplot not how to display the data, but when I say, so y is going to be life expectancy, x is going to be GDP per capita, and those are columns in Gapminder, but we haven't told it how to display it yet. So then when we say plus g on point, then it knows what to do. So in particular, this is just one layer. There can be multiple layers. So here it says one layer, and the only layer in this case of the visualization is going to be g on point, which stands for scatter plot. So scatter plot is just points on the plane where, you know, the x and y coordinates are whatever is specified. So that looks like this. So here is exactly the same thing, except instead of saying g on point, we say g on smooth. So g on smooth says display the data as a smooth line. And of course, like there's like multiple of those. At first, it's just going to be examples. There's also kind of a comprehensible list of everything on just the ggplot website. Right. So here, this is the same. So we are working with the same data frame, same columns for x and y, and then the difference is here we're saying display it as a smooth line, and then here we're saying display it as a scatter plot. So here there's various options. So the method refers to how exactly you draw the smooth line through the data. So the particular method is Loess here. And then SE equals F means that you don't display the ribbon. A ribbon is something like this, where the shaded area, so the gray thing is called the ribbon, so that displays basically the uncertainty about where the line should be. So, okay. You can do both at the same time. So you can say, okay, we're working with Gapminder, those are the columns, and then you say add the layer that's the scatter plot, and then you can say add the layer that's the smooth line. And in this case, so usually it doesn't really matter, but in this case we said first put the scatter plot and then put the line, and that is why the line is on top of the scatter plot and not the other way around. And usually that's what you want, because if it were the other way around, you would just not see the line most of the time. It would be obscured by the scatter plot. This one is without SE is equal to false. So that's why you're also displaying this ribbon that indicates the uncertainty about where the line should be. So you'll notice that the ribbon is very wide here and it's very narrow here. And the reason is very simple. It's just that over here there's very few points, so it's not super obvious where the line should be. Whereas if there's a lot of points, then there's not a lot of uncertainty about where the best line is. So the exact method of how you determine the uncertainty kind of depends on the method that you use in order to draw the line in the first place. So here we're using a different method for drawing the smooth line. So specifically we say LM. LM stands for linear model, and that just draws a straight line. And as you remember from last time, drawing a straight line is not a great idea for this data. So looks kind of like this. So here we are using the scale x log 10 layer, which transforms the x-axis. So it's the same way, except it's saying display the same data, right? So we're not changing the data, but we're displaying it differently. So basically what we're doing is we're stretching the x-axis over here, and we're compressing it over here. And the way it works is, well, like this is 1,000, and then this is 10,000, and then this is 100,000, and they're evenly spaced. So what does it mean that the distance from 1,000 and 10,000 is the same as the distance between 10,000 and 100,000? Well, it means that you're just compressing the x-axis by a lot on the right. So specifically, how do you uncompress and compress the axis? Well, it's just that you take the log of x, and then here you're plotting basically the log of x. So here, log base 10 of x is 3, log base 10 of x is 4, log base 10 of x is 5. So that's another way of thinking about how you compress and uncompress the x-axis. Does that make sense? So, okay. So here, look, there is like lots of stuff. There's no way to cover all of it, but here's one thing you can do. So you can say that the label on the x-axis is actually in dollars, and you can specify that it's actually in dollars, and then it'll display it as dollars. So that's nice. And you can kind of see that like the data visualization here is getting better and better, right? So we went from, well, so here it's a little bit arguable, but we went from this, which is completely terrible, and doesn't really tell you what the trend is because you're drawing the trend in an incorrect way because the trend is really like this and you're drawing a straight line. And here you're displaying like 30,000, 60,000. And then we went to this, which is arguably kind of better, but you have to think about, okay, like what's 1e plus 0.5 in dollars? I mean, it's not that difficult, but you want to make it as obvious as possible. And then here you display the units, and because it's dollars, R just by default, you can always force it, of course, but R just by default displays it in units that make sense for money. So this is much better, and it shows, okay, like there is clearly a trend here. So you can alternatively, like it doesn't look as good, but when you're experimenting, it might be the thing that you would try. You could say instead of X being GDP per capita as before, you're saying X is going to be log 10 GDP per capita. That's exactly the same thing. It's just that it doesn't display as nicely because here we just display like log 10 GDP per capita is 3, 4, 5. So you can do colors and stuff. Here, for example, you plot it as orange, and here you can say I want the smoother to be black. This I wouldn't do. So of course, there's just different aesthetic preferences, but in general, I would say that just making things a different color for the sake of it is distracting. Now, if you're used to something in the way I'm kind of used to the default way that ggplot displays things, so like blue smoothers and black points. If I see something like this, it takes me a few seconds to adjust and to figure out what's going on. So I wouldn't do this. Now, of course, this is for me specifically, I'm used to ggplot. If your audience is not used to ggplot, then it kind of doesn't matter as much. Although if you select colors that are particularly pretty, arguably, okay, it's nice that you have pretty colors, but arguably the prettiness is going to distract from the information being conveyed. So here you can do something kind of more fancy. So here the example is you are displaying, so here we're doing scale x log, we specify the labels, and then we kind of label the axis. So usually it's better to say in English, so here we kind of set, okay, like this is like this, and then we do it like this, and here you have whatever, like title, subtitle, whatever. Here you have like a small caption that says the source is Gapminder, stuff like that. So another thing that we've done here is we set alpha to be 0.3. So the alpha is the transparency measure. So before, if you remember, all the points were just black. Now we're making the points kind of grayish. And then if there's points that are overlapping, then we're displaying a darker color. So that allows you to display more information, because before, if you had a clump of points that were all on top of each other, you couldn't tell. Now you can tell where there is a concentration, where there is not, so that gives you more information. Now, there is a trade-off in terms of, is it really good that now you have this extra information, or is it distracting? Well, depends on what you're trying to convey. So finally, there's different themes. If you, like me, like The Economist, you can have The Economist is a magazine. I guess officially it's called a newspaper. So you can have like charts in the style of The Economist. just kind of out of the box if you just say theme economist. And there's various themes, so you can pick one that you like. So far we're basically displaying like y versus x and then making it nicer. So here's a way to display more data than just y versus x. And the idea would be, okay, like we used y for life expectancy and we used x for GDP per capita. Well, maybe you want to know how things are on different continents. And one thing you could do is just a different chart for each continent. That's an option. But in fact, you could just say, well, I'll use color in order to indicate which continent the data point came from. So here it would be that the red dots are from Africa, and then the points in green ones are from the Americas, and then is it turquoise? I don't know. So something like this from Asia and so on, right? So this is really where ggplot is kind of just conceptually interesting. It's all uniform. You just say my mapping is the x-axis is this column, and then the y-axis is this column, and then the color is this column, and it'll just automatically say, okay, I'm gonna use color in order to indicate which continent this came from, right? So that's just kind of like I think it's really cool. So the overall kind of philosophy behind the design of ggplot is called the grammar of graphics. So this is an idea that was developed kind of in the 80s. And the idea, so I kind of tried to give it through examples. The idea is basically, and like it's never completely perfect, but the idea is basically we separate out what the data means from how we display it. So here, what the data means as well, like we have one column that's GDP per capita and one column that's life expectancy and one column that's continent. And then we tell ggplot, okay, like this is the tool that you're going to use in order to display this particular column. So maybe it's the x-axis, maybe it's the y-axis, maybe it's the color. And then separately we tell it, okay, now that you know how to present each column, the specific method I want to present the data is geom_point, so that means scatter plot. So again, just points on a plane. So that's kind of the basic idea. Now, I don't know whether I should teach kind of a lot of this, because part of it is it used to be that you had to really think very hard about what you need to do. Nowadays, if you kind of know what you want, you can just tell ChatGPT to write the code for you. And in fact, that's how I work now, right? So like I want a particular chart. I mean, I could think it out, but why would I? I can just tell ChatGPT, this is what I want, and it just gives me the code. It's not always right, but it's easy to check. And if you're not happy, you can change it. So I think kind of the usefulness of knowing kind of the exact syntax is maybe less. What is still useful, of course, is knowing all the different options that you have, because if you don't know what to ask for, ChatGPT is not gonna give it to you. And of course, sometimes the code is wrong, so you need to be able to fix whatever ChatGPT gives you. So yeah. That's kind of all I had for today. So if there's questions. Yeah, so hopefully people did find the link. It was on the website, I posted it. So yeah. Someone's typing. Yeah, so ggplot. Well, so Python does have Seaborn, which is quite similar to ggplot, And no, matplotlib is like, okay, yes, that was a joke. So yeah, don't use matplotlib. So like, yeah. So Geom Smooth, I only know, so there's LM, there's LOS. So in general, just like ask R, it'll give you all the options. So LM, LOS, you probably want some kind of polynomial fit as well, which is also available, stuff like that. So ggplot is also just, I think there's libraries where you can literally just input ggplot code into Python just as a string. It's fine. But I think kind of one of the big advantages of R is actually kind of how nice the ggplot syntax is. And this is something that you can do in Python, for example. So in Python, you just cannot say like x is equal to GDP per cap. I mean, you can, but it would mean a specific thing. It wouldn't mean like bind GDP per cap to x. So in this way, I think R actually works really nicely. But again, it used to matter more before ChatGPT. Now, whatever, you can, like, if you know what to ask for, ChatGPT is just going to do it for you, even if it's a little bit more awkward. I do not know. It's it's not that similar. I think I know about TIGS. I don't know what PGF TIGS is though. But so I don't know. Yeah, nobody really understands matplotlib, but well. And again, I think kind of this used to be a lot more relevant when it wasn't the case that you could just tell ChatGPT in English what you want. So I think the skill set that's actually required now is familiarizing yourself with the options, and the data visualization textbook is very good for that. And then once you know the options and once you know what's named what just in English, you could just say, I want this. I mean, if it's just the LaTeX one, then it's not similar. So TIGS is the LaTeX one. If PGF is just like some variation in TIGS, then it's just not similar. All right. Well, I'm done. All right. Okay, I'm gonna fly away. I'll be in touch. Yeah, I'm sorry that so like the grade scope kind of broke on me, and I can't figure out how to fix it. But I will, and hopefully today. If not, then hopefully tomorrow. But you can submit kind of problem set 2 whenever. I'll have a small problem set 3 that's going to prepare you for the project, and then I'm going to post the project in about a week.
Thank you.
All right, cool. So R and tidyverse. So I would recommend. So I would recommend, so just search for like our tidyverse Heavy Wickham. So he has a free textbook that's online. That's very good. All right, I will see you in September. I hope you get some rest. Gonna be a difficult year, probably, but hopefully fun. All right, see ya. Bye.
Yeah.